Hello everyone, my name is Daksh Joshi and I am a science teacher, especially physics, and I teach physics for 9th and 10th class. Today it is a demo video, so we are going to teach motion, which is a part of class 9, and in that we have to study the distance and displacement, also motion and rest, and the definition of motion and understanding the distance and displacement with examples, vector and scalar SI units, and the difference between distance and displacement, vector and scalar. These are the part of this chapter. Now we will start the chapter that is motion. First of all, we will have to understand the term motion. Motion is the position of an object with respect to surroundings and time. Both are important, but surrounding can be changed or cannot be changed. But time always running, which means if you start a watch from zero, it start and it end when you stop it. But time is always running. It is your watch which you measure it. So time is an independent quantity. It is always running. You will just take it as a reference. So we study motion in the branch of physics, that is mechanics. Mechanics have two part, that is kinematics and dynamics. Kinematic means study of motion without the source of motion, which means we do not know how an object start its motion or is at rest. Second point, dynamics is the study of motion with the source of motion that we know. Which means if we know that any object start motion with the force of T Newton, then it consider it in dynamics. If we do not know, let us say, take an example. If a car is moving at 10 kilometer per hour, this motion do not have any data regarding starting of the motion, right? So it is considered in the part of kinematics. Now let us move to motion and rest. An object is said to be in motion if position is relating to its surrounding change in given time, which means surrounding and position of object changing, either changing of surrounding, I think changing of object with respect to surrounding, which means we take surrounding as main part to consider the motion. If the surrounding is moving with respect to object, then it is at motion. Now we have to take an example by seeing these two images. In the first image, the tree is in front of the car, but in the second the tree is behind the car, which concludes that the tree is moved away from the car, which means we understand that the car is moving. How we can understand? With the understanding of surrounding motion, right? Now move on to the type of motions. There are three type of motion: translatory motion, rotatory motion, and vibratory motion. Translatory motion is motion of an object move from one point to another point in space, in any path, straight line or curve. If it is moving in a straight line, it is called rectilinear. If it is moving in curve path, it is called curvilinear. Let us take an example by seeing that a car is moving in a road. It is called rectilinear motion. Sorry, means rectilinear motion. And a car is moving in a curve path. It is called curvilinear motion. Now moving to rotatory motion. When an object spin around its axis is called rotatory motion. Simple. You can see that object of a Beyblade. Okay, that is the motion of rotating motion. Vibrational motion, it is the motion of an pendulum. The vibration motion is the motion from its mean position. Mean position is B, and it moves from A to B, B to C, C to B, and B to A. Which means at the end of the motion, it is always at B, which we call oscillation, that we study in the higher classes or in the end of uh, in the chapter sound. Okay. Now we have to understand distance and displacement with taking an example. Let us take an example: a bus moving from A to B and B to A, and it completed its journey at A. By it is a round trip. So now distance is the measurement of path, actual measurement of path. We do not include the direction for the measurement, but if we include the direction and take the shortest path between initial and final point of an object in a motion, right? Now, we'll start from A, then it end at B, and again B to A. If we see, the initial point is A, and the final point is also A. So the distance between initial and final position is 0 because initial and final point are same. This considered as displacement, which has direction and magnitude. But if we going for the distance, which is actual length of the path which we travel, right? That is 150 plus 150, that is 300 kilometer. 300 kilometer is the distance. So the displacement is 0 because initial and final position points are same, that is A, right? Now move on to SI unit and SI unit and vector and scalar quantities. SI unit of displacement. First of all, we have to understand SI unit. SI unit is the considered as the general unit made to use to measure that particular quantity, right? That is, if we consider distance and displacement, we have to measure the same magnitude in displacement as well as in distance. In displacement, it is called shortest distance. In this distance, it is called actual length of the path. But the magnitude measurement is same, that is meter. So SI unit of displacement and distance are same, that is meter. Now moving to vector and scalar. Vector are having direction with magnitude, but scalar have only magnitude. So distance is scalar because distance has only magnitude, but displacement have direction and magnitude, right? Because the definition of displacement is the shortest distance between initial and final position, right? Now move on to the formula of displacement, that is x final minus x initial. The x final is the position of an object which is in motion with respect to the origin, which we study with the help of number line system. Now let us take an example of case first. Now an object start from +1 and move to +4. Now the initial position from the origin is +1 and the final position from the origin is +4. We know the initial point and the final point positions. Now we have to put it in the formula of displacement, that is x final minus x initial. X final position from origin is +4 minus initial position of object, that is +1. Now the resultant will be +3. Now we have to understand the significance of signs, that is plus or minus. If we have plus sign in the resultant of displacement, then the motion of an object is in the direction of motion, that we consider. If it is negative, then it is opposite to the direction of motion. Let us say we consider the direction as positive, so the motion is in the direction of motion. Motion of an object is in the direction of motion. If the object move to opposite side, then it get a negative sign, which we consider in further cases. Now let us take this case 2 example where initial position is -3 and final position of is -1. But you will see the motion is in the positive direction or the direction of motion. It is not in the opposite direction. That's why it got plus. Right now, case third diagram is there. The motion is opposite to the direction of motion. The movement is opposite to the direction of motion. That's why we got -2. That we understand earlier. Why we got plus and minus sign. Okay. In this ninth class, we only study straight line paths. Okay. No circular path. Only understand a term circular motion at the end of the chapter. But all the numerical are based on straight line paths, right? Now it is enough for that class. Thank you everyone. It's my demo video for the position of one-to-one teaching or content creation that we have given in the Google information page. Thank you everyone.